This is the second problem I solved regarding capacity when 100% of flow does not pass through all resource pools, through all stations. Let's think about a department of motor vehicle when individuals go there to renew their driver license. 22 customers come in per hour. That is 100% of arrivals. 30% of them, the department is concerned with their eye health, and therefore they need to go into an eye test. And 20% of them, the department is concerned whether they still know all the driving rules. They go to a written test. Out of those people who go to eye test, 80% pass the test, and therefore 20% go out. 20% of what? 20% of 30%, which is 6%. 6% go out. Here we have 20%, 80% of 30%, which is 24%. They also come in. Therefore, here together we have 44%. Out of that 44%, 90% pass and 10% therefore fail. 10% of 44% is 4.4%, and the rest, which is 39.6%, go over there. 39.6 come here, and 50% also come here. The total enter the final process is 89.6, and 6% from here and 4.4% from here leave the system. So here, out of what comes in, 80% goes to the next process and 20% leaves the system. Out of what comes into the written test from here and from here, from eye test and from reception, 90% goes to issue license and 10% leaves the system. They cannot go through the final stage of the process. I think this is clear. These green numbers are capacities. If I ask you where is the bottleneck, if you don't think, you may say, okay, the capacity of this one is the lowest, therefore that is the bottleneck. That conclusion was correct if all flow units would have passed all resource pools. But it's not the case here because some drivers go to eye test and fail and leave. Some drivers go to written test and fail and leave. Therefore, not 100% of all flow units pass all processes. We will see what is the bottleneck. Now let's summarize. 20% of 30% is 6%. 80% of 30% is 24%. 24% and 20% is 44%. 10% of 44% is 4.4%. And the rest is 39.6%. We also have 50%. Now we can multiply each of these percentages by what comes in to compute the throughput of each process. So that is computations that I just did. And this is what, if we multiply each percentage by the actual throughput. Each percentage by the actual throughput. Each percentage by the actual throughput. 50% of 22 is 11. 20% of 22 is 4.4. 30% of 22 is 6.6. So this is the throughput to all stations or all resource pools in the system. Let's look at the first process. 22 customers come in, 22 go out, and the capacity of the process is 44. If we compute utilization, that is 22 divided by 44. Therefore, the first process is 50% occupied. Go to the eye test. The capacity of eye test is 10, and throughput is 6.6. Therefore, I can apply the same there and I can compute utilization. And therefore, utilization here is 66%. The next place is return test. Capacity is 12. What passes that process is 9.68, and therefore utilization is 0.8 something. And for the final process, out of 22, only 19.712 passed that process, and the capacity of that process is 42. And therefore utilization is 0.46. At the beginning, when we looked at these four processes, we thought the process with lowest capacity is the bottleneck. But now we need to look at utilization. Which station has the highest utilization? The highest utilization is here. Therefore, this is the bottleneck. And the capacity of this system is throughput of the system divided by utilization of the bottleneck. $22.867 equal to throughput divided by utilization of the bottleneck, and the capacity is 27.27 per hour. So based on utilizations, capacity of the first station is 44 customers. Capacity of iTest is 33 customers per hour. Capacity of written test is 27 per hour. Capacity of the last station is 46 per hour. And out of these numbers, the bottom is here. These are the nominal capacities, but because not 100% of flow passes through all processes, these are the actual capacities. The first one, because 100% of flow go there, the capacity remains 44. But the second one, because only 30% of flow goes over there, in terms of the number of customers that they can come in, it is 33.3. In the written test, only 44% of customers go there. Therefore, when the capacity nominally is 12, and that's 12 if 12 come over there per hour. Not all those 12 come in, only 44% of 22 come in. Therefore, capacity of this station in terms of the number of incoming clients is 27, and this is the capacity of the last station. And again, here is the bottleneck. Thank you very much for attending this session.